Machine learning, or ML, is the process of teaching a machine or a computer how to perform a task such as identifying fraudulent credit card transactions. Before machine learning, using classical programming, developers spent many hours creating logic rules and applying them to a specific data set to calculate an answer. Now with machine learning, developers can create computer algorithms that can learn from experience without relying on rules-based programming, thereby moving the heavy lifting away from humans and onto machines. Machine learning is good at solving problems, like predicting the price of a book based on its features, such as the number of pages, the author, and whether it has a hardcover or not. It also excels at solving classification problems like determining whether a movie review is positive or negative. Machine learning components. Data. The data to solve a machine learning task consists of features and a label. Feature data are the inputs, or X variable, the known attributes about the problem your task is trying to solve. Label data is the output, or Y variable, the value or attribute you are trying to predict. ML data types can be either categorical such as a movie genre, or numerical such as a book price. Algorithms. A machine learning algorithm is a set of instructions a computer runs to determine the rules that allow it to predict a label or output in a dataset. There are two types of machine learning algorithms. Supervised ML algorithms use data with labels, or the observed output, already included with the feature data. Supervised ML algorithms are suited for solving problems involving linear regression and classification. With unsupervised ML, the labels are not provided as part of the input. Unsupervised ML algorithms are better at solving clustering problems that find naturally occurring groupings. Machine learning lifecycle. The machine learning lifecycle involves determining the business problem with goals that are specific and measurable. Defining the machine learning model by rephrasing the problem using ML terminology, and then identifying the type of algorithm that is best suited for the task. The next step is to prepare the data, which requires gathering, merging, and cleaning up features and label data. Once the data is ready, you train and test the model, and tune hyperparameters until the desired accuracy is achieved. The final step is to deploy the model to production, and then evaluate it to improve the predictions by iterating over the previous steps.